Sure that you all have heard artificial intelligence is a term, right? But let me ask you a question. What do you really envision when you hear artificial intelligence? What's the first thought that comes to your mind? And I've been doing this, pop quizzes with various audiences across the past 1 year. And, here are some of the most common responses that I get. And I'm sure that, for many of you, these would be the first imagery that comes to your mind. For many of the people, when they think about AI, about artificial intelligence, the mind immediately races towards some super intelligent humanoid robot, the kind that you see in sci-fi movies, right? Like Rise of the Machines and so on and so forth. Another image that really comes up to all of us is a driverless car, a self-driving car, right? Again, it's been in the news. There are experiments happening, there are pilots happening, so that is a very distinct reality in not so far future. Or to the more nuanced, prospects and folks who've been reading about this a lot, I'm sure AlphaGo is an image that comes to mind, wherein for the first time a machine actually defeated a human consistently in a game of Go. But there's one common aspect to all these images, right? Which is that we are looking at a world where machines or computing systems, if I may call them in more simplistic terms, computing systems are actually making decisions like human beings do. And that really is the crux of artificial intelligence, right? If we remove all the fluff around it, if we remove all the jargons around it, what AI really at the core of it means is how do you make machines behave and take decisions like human beings with better accuracy and better predictability, right? So that is what all systems are trying to achieve today as we speak, and that is the world that we are moving into. Broadly, when you think of AI, when you think of artificial intelligence, there are broadly three categories of that these fall into. The first is what is known as narrow AI. Narrow AI is where you have developed an algorithm, or or your machine or computing system is extremely capable of doing one task and performing it at an accuracy like humans or better than humans, right? But it is only for that one task, right? So a very common example that you may all relate to here is image recognition. So one of the pioneers, or one of the companies that has done really very well when it comes to image recognition, face recognition, is Facebook. And I'm sure all of you, if not most of you, are Facebook users, so you guys know what I'm talking about. When you upload pictures on Facebook, nowadays, the Facebook algorithm doesn't really ask you to tag them. It is able to identify who these people are. There was a time until about 12 months back when you had to actively tag people, right? right? Or there were suggestions that were coming, and nowadays for most cases that does not happen, right? So that is an AI algorithm that they built, which they call as deep face, and the deep face accuracy of recognizing faces, by the way, is 97%. It is currently higher than human beings. Human beings have an average accuracy of about 92%. The deep face algorithm has accuracy of 97%. So that is a classic case of narrow AI, where that one algorithm, right, the only task it has to do is recognize faces. Obviously it's easier said than done, but that is the one task that it has to do, and that it performs at comparable or at better accuracy than human beings, right? So that is an example of narrow AI. The other broad category of AI is general AI. General AI is where there is also context. It is not just about one task, but it's about a series of adjacent tasks, and now the machine is able to perform those tasks, right? To relate that to an example, a perfect example would be any of your voice assistants, whether it is Google Assistant, or whether it is Siri, or whether it is Alexa, right? In all of these cases, it is not as if you're restricting your query only to one aspect, right? It's not as if you only ask Alexa about the weather today, right? Or you only ask Google Assistant about, what's my schedule for the day, right? You're asking these systems, these machines, a bunch of questions, a bunch of adjacent questions where there is context, and the algorithm is working and learning in such a way that it is aspiring to improve its accuracy and responses over time, right? And for any of you who are active users of any of these voice assistants or chatbots, you would see that over a period of time the accuracy improves. Over a period of time the system starts learning what you really mean, right? And starts giving you better responses. Essentially, in many ways you are training the machine, and that is what AI is all about. But the machine is learning, right, to respond better. So this is a classic example of general AI, where the use case is not restricted to one specific task or one specific area, but there are adjacent areas, and there is a context around it, and the algorithm in the machine has to be trained enough to pick up that context and thereby give responses or give insights or answers that are more meaningful. The third category of AI is super AI, as the world calls it. So when you talk of super AI, it basically, you're talking about a world that has built machines that are just much smarter than human beings in everything that humans do. Right. So imagine, a movie like Matrix coming to life, for example. Right. So it is of a world like that. And obviously, this today is in the realm of fiction. Whether it will happen and when it will happen is a different matter altogether. And I don't think that is what we want to talk about today. But this is far from reality right now. Narrow AI and general AI is where a lot of work is happening. A lot of evidence is already proved out, and you already have systems that have been built out to take use cases and applications in these areas, and they're getting better with time. Super AI is futuristic. Super AI right now only exists in Hollywood movies and fiction novels. And in fact, one of the quotes that I really liked about this whole debate about whether AI will take over the planet and whether humans would be delegated as slaves was given by Andrew Ng, one of the foremost thinkers on this area, and he mentioned that that he worries about super AI in the same way that he should worry about overpopulation in Mars, right? So it is that far thought, right? But let that not distract you from the application and the reality of AI that surrounds all of us today. On that note, let me take you one level ahead, one level deeper, right? And let me try and explain to you three terms that are often used interchangeably and often quoted out of context, right? But one of the things that I thought I should try and do is also demystify some of these things for you, right? So we've spoken about AI, that what does AI really mean? AI is essentially, you're talking about developing algorithms, computing systems, and machines in such a way that they can understand context, understand data, and give output, whether that is insight, whether that is information, any of the output that the system is supposed to give, at a rate that is comparable to humans, or at an accuracy rate that's comparable to humans, or slightly better than humans, right? So that is the broad world of AI. Now, there are two other associated terms. One is machine learning, and the other is deep learning. First, let's talk about machine learning. So, machine learning, the science of machine learning, it's a complete field of computer science, right? So, it's an entire field of study, and that is something that we all need to appreciate, right? It's a very vast and deep field. The field of machine learning is all about creating algorithms using certain techniques in such a way that you can train these algorithms over a period of time as there is more data that gets ingested, right? So the algorithms start learning and start becoming smarter, thereby their output starts improving over a period of time. And machine learning and AI are very related because machine learning is one way of implementing artificial intelligence. Machine learning is a set of techniques to implement AI, right? That is the connection between the two. So obviously the question that may pop up in your mind is that can you do AI without machine learning? And the theoretical answer to that is yes, you can, right? You can implement AI without machine learning. But to implement AI without machine learning, the effort and time and investment that's going to go in, to maintaining millions of lines of code and constantly updating it and deploying it is a lot more, and that is why it is not feasible. Which is why the only practical way of implementing AI is through machine learning, right? So you really cannot advance in AI unless and until you know machine learning, because that is the only way that AI will get implemented in a scalable and sustainable fashion, right? Because as I said, what the systems that you're building, the engines that you're building by using machine learning are in such a way that they improve over a period of time, so that your effort does not increase non-linearly as scale of data increases, right? Because then it's not sustainable, right? Which is why machine learning is important. Machine learning then further breaks down into multiple categories, whether it is supervised learning, unsupervised learning, reinforcement learning. All these are a bucket of techniques depending upon the problem you're trying to solve. But all of these are means to an end, and the end is essentially implementing a broad AI solution, right? So what is important for you to understand is that machine learning is a way or a means of implementing AI. Then what is deep learning? Deep learning is an alternate set of techniques that you will deploy at some point in time when you want to take the accuracy of your system even higher, where machine learning models can only take it to a certain scale, and then you deploy deep learning techniques to increase it even further. And I'll explain that with an example. But the broad difference here is that deep learning, the whole science and field of deep learning, is all about creating algorithms or creating systems in such a way that they mimic the human brain, right? And obviously there is a lot of science behind that, right? When you think about the human brain, right, you know that its capacity to analyze, to consume information, to give insights is practically limitless, and it is able to do all of this gathering the context that exists around it, right? So deep learning is when you are actually trying to build solutions, right? When you're trying to build computing systems, machines, or algorithms in such a way that you are able to enhance what machine learning has already achieved, and you're trying to take it even further. Now, for every problem that you face, it is not as if you need to build a solution using deep learning, right? It really depends upon the level of accuracy and the complexity of the problem, the level of accuracy that you want to achieve, and the complexity of the problem that you're trying to solve. In today's world, there are far more applications of machine learning, and that's why there are so many jobs in machine learning. And deep learning is something that is now beginning to kick in, because for a lot of these organizations that are implementing machine learning solutions, one of their focus areas is also how do you enhance on top of that, and that is when areas such as deep learning come into prominence. Let me go back to the example that I was explaining to you, which is image recognition. The deep face algorithm by Facebook, right? So image recognition is typically one of the first examples or case studies or walkthroughs that you will come across when you begin your journey in learning machine learning, right? It's a classic machine learning problem. So when Facebook, now if we think back about the journey that the machine learning engineers and the AI engineers would have made at Facebook to bring deep face to life, right? Obviously, what is the problem that they are trying to solve? The problem the problem that they're trying to solve is that they have to build an algorithm that recognizes human beings on the basis of pictures that they have, right? Now, typically, when you try to solve such a problem, it is not as if you immediately jump into one solution and start building it, right? You will first start building a model on a smaller data set that gives out a certain set of results at a certain predictability, right? Now, go back in time, and all the times when you were actually tagging people manually, what you were doing was that you were training the algorithm. You were training the algorithm with data. You were saying that, okay, this picture belongs to this friend of mine who is by this name, right? And this other picture also belongs to this friend of mine who is by this name, right? So by doing that, by millions of people doing that, the algorithm was getting trained, right, in terms of how to ingest input and provide output, right? So a lot of that initial work would have happened using machine learning techniques, right? But by using those techniques, there is a certain level of accuracy that you would have hit, maybe like an 80% or an 85%, right? The journey from 85% to 97% cannot be achieved only on the basis of machine learning techniques, right? That is where you bring in deep learning. That is where you enhance what has happened, and you now try and mimic the human brain, right? And you try and increase its accuracy from 85% to 97%. In some companies, or for some problems, 85% is good enough, and you would never implement deep learning, at least not immediately. But for some problems, you need that level of accuracy, and the problem is so complex. Why is the problem complex here? Because, as you would imagine, facial features of people change, right? People grow beards, they grow fatter, they grow thinner, they grow older. All of that happens, but your algorithm still has to give the right result, right? So you have, there is a vast level of complexity when it comes to just this specific problem, right? One of the first case studies that you would do in machine learning, for example, is like a color recognition problem. Where you would build an algorithm to essentially train the algorithm on picking up colors, right? So first you would train the algorithm with different colors, and you'll get till a point where you show a card to a computer, and using the webcam the algorithm functions in such a way that the algorithm is able to pick up which color this is, right? Now in this, right, to get to whatever 95% accuracy, you don't need any deep learning because the problem's complexity is limited, right? So there you can do it with machine learning. But change that problem scope to recognizing human faces, then the whole scope of the problem completely changes, right? And then you get constrained by machine learning because it brings you to a certain point, and then to cover the gap from there to higher degrees of accuracy, you need deep learning, right? So that is how deep learning gets implemented, right? This is the common relationship between these three terms that you would otherwise very commonly encounter, right? So remember that AI is the broad umbrella of essentially training algorithms or training machines to understand input, analyze input, and thereby give output or give insight like human beings do, or better than human beings do. Machine learning is one way of implementing AI, and it is the most feasible and scalable way of implementing AI, which is the reason why there is so much demand for machine learning right now. Deep learning is an alternate way, which many times is used as an enhancement on machine learning, right? So that those results improve, or the problem complexity is such that you need deep learning solutions, right? This is how these three terms are related. At the crux of it, machine learning is always a path to implementing AI. So there is no AI without machine learning, right? You can't directly start learning AI if you don't know machine learning, for example. Which is why even in our program, you first become really good at machine learning, and it is only then, once you are strong on machine learning and you understand and you have gotten enough exposure and experience of implementing machine learning solutions, do you progress into deep learning and AI. I thought, at this point in time, if we step back and look at what is really happening in the world around us and why are there so many new terms that are coming about, it may help us to understand, this space much better. And that's what I've tried to do here, right? And I think all of us will acknowledge it. It is no surprise now that we are living in an age of data revolution, right? right? What is disrupting businesses and industries altogether all around us is data, right? Data is driving growth, and data is driving this revolution that we are breathing in currently. And if you look at the evolution of this whole data revolution, right, you will see that it began with something known as business intelligence, and that is what I've been trying to, or I'm trying to depict through this infographic that you see on your screen, right? So it begins with business intelligence, goes into analytics and predictive modeling, then goes into data science and big data, then goes into machine learning, and then finally it progresses into AI and deep learning. And let me explain how this landscape works. And the core component that is connecting all of this is data, right? Is the data explosion. So when you talk about business intelligence, right, this is primarily about looking at data and reporting about things that have happened in the past, right? So it's a lot about dashboarding, creating reports, but it is all about what has happened, right? And that is where there was a lot of demand and a lot of business activity happening in the early 2000s, right? 2000 to 2007, 2008, right? There was a huge demand in that, right? Because suddenly data could tell you a lot of things that have gone wrong, right? That have happened in the past, right? And it could be depicted in a very visually uh, or easy to understand manner, or visually appealing manner, right? And that's why there were so many takers for it. Then around 2012, the world started moving into analytics and predictive modeling. Here again, the core component was still data, right? But the difference was that the same data was now being used to predict the future, right? It was not just about, okay, I will understand the sales data to see, or I'll look at the sales data of the last 4 quarters to report what has happened in the last 4 quarters at a city level, state level, etc., etc. Right? Now, the problems that were getting solved around 2012 was that I will look at data from the last 4 quarters, and I will now try and predict what is going to happen in the next 2 quarters, right? So that was the whole world of analytics and predictive modeling, which even today has demand, right? Today, even today, there are a lot of companies that are implementing analytics solutions. There's a lot of demand on that front. Then what happened about 4 years back is that there was this whole explosion of big data, right? So suddenly data consumption and data generation really increased in magnitude, right? And there was a lot more data that companies actually had to process and infer decisions from in a really short span of time. That is when the entire world of data science and big data came about, because now it was not just about having the ability to predict using data. That was of course needed, but it was also about how do I handle such large volumes of data and such large variety of data, right? Structured data, unstructured data, all of this, how do I handle this and create models that can actually predict some decision or give me some insight, right? So that was the whole field of data science and big data, where analytics was a part of it, right? And the other part of it was the whole big data technologies, right? So those combined to make data science. Again, this was something that was a lot in demand, but as time progressed, what also happened is that these things became more platform driven, so it became easier to do. But even now data science and analytics definitely are areas where a lot of companies are looking to onboard people. In the last 2 years, what has come about as a big change is machine learning, right? So machine learning is now an extension of the same data science, where it is not just about predicting the future, but it is also about building algorithms or building systems in such a way that they get better with time. Right? So you train the algorithm, you build the model, you train your model, you train the machine, right, to solve either one specific problem, or as we discussed, an adjacent set of problems in such a way that the machine learns over a period of time, the algorithm learns over a period of time, and it gets better with time as more and more data it consumes, right? So that is the world of machine learning. And then the adjacent field, the further improvement is AI and deep learning, which, as we've already discussed in great detail, is an extension of machine learning, where you are trying to either solve more complex problems that have been built on machine learning paradigm, or you are trying to solve you are using the machine learning models to solve a problem, and then building on it to actually enhance its accuracy even further, right? And that is the entire world of deep learning and the associated areas within AI. So this is the evolution of data, right? This and what we are seeing in the industry right now is depending upon the data maturity and adoption that various organizations have. They are at different stages of this curve. What is inevitable is that everybody will move up the curve, right? That has been proven time over again, right? So that is inevitable. Different organizations and different industries currently reside at different stages of this in terms of what they are being able to do with data. But at the same time, everybody is moving in a direction that is upward, right? Which is why today, as I said, there is such a huge demand for machine learning and AI, because that is the future, right? And machine learning is already here. It's not even the future. It's happening right now. And there are a lot of companies that are in that phase. There are a lot of companies that are moving up the adoption curve from data science and big data into machine learning. So I hope that kind of gives you a rough idea of what the space looks like, and what is the interconnectability, right, between these different terms, right? And what is important for you to really appreciate and understand is that this is a journey that organizations make. So everybody, what their name is now past business intelligence, right? Companies are, or organizations and industries are between the stage of analytics and AI and deep learning, right? The tech companies are mostly between machine learning and AI. The other industries are between analytics and data science, and they are all trying to get to the next level, right? So hence, if you are skilled in this side, on this side, and if you can pick up the skills in machine learning or AI, the future is yours to take, right? Which is why it's such an exciting time to be a professional who's really good at these skill sets. All right, so I hope that kind of clears some queries. Let's move on that front. This is a simple infographic, which, as you can imagine, throws out a lot of numbers. But this is the impact of AI today, right? There is a 50% annual growth rate increase in AI spends. It is projected that $58 billion are going to be spent by companies by 2021 just towards AI. Enterprise AI revenues are predicted to be $31 billion by 2025. 84% of companies, and mind you, this is not just it's not as if none of this is happening in India. A lot of this action is happening in India. 84% of companies are investing in AI, right? So you can, these are clear shifts, right? And relate it to the previous infographic, that this is the adoption curve that I'm talking about. This is how companies move up the adoption curve in the data revolution, right? What is clear is that the data revolution is here and it's happening. What each of us have to really decide is that what role do we play in this revolution and what can it mean for our careers, right? So hence, you have to figure a starting point for yourself, right? And machine learning and AI are great starting points because that is where the world is converging towards. So like that, you can see there are multiple data points here, all kind of projecting to how AI is changing the world. In fact, let me look at this interesting statistics. In 2010, the error rate for image labeling, which is a subset of image recognition, was about 28.5%. And 28.5% error rate, which means about a 72.5% accuracy rate, is not good enough to implement any solution, right? Because there's far too many errors. Like 1 in 4 is an error response. In 2017, right, the error rate for the same problem is 2.5%, which means accuracy rate is 97.5%. That is where the needle moves, right? When you hit those kind of numbers, then it is a given that problem is solved and that problem is going to get implemented in mass across industries. And that is what we are seeing increasingly with every problem, right? Every problem that's coming into the machine learning domain and then progressing into the AI domain. That is how accuracy rates are improving, and that is how these are becoming, large scale implementations across organizations. I'd also like to draw your attention your attention to the last fact here, that the growth in jobs requiring AI and machine learning skills since 2013 has increased 4.5x, right? And that is a massive jump, and that jump is going to increase even further as we go along. And it's evident in many ways, right? This clearly explains why everybody is learning AI, and it is a race right now to become an AI and machine learning professional. And the later you start on that learning journey, of course you are at a disadvantage, right? Because it's not as if opportunities will go down, but opportunities will only increase. But of course, the people who have a head start, they have a first mover advantage, and they want to build better careers. So this is a graphic that I was able to pick up from some of the leading global universities such as Stanford, Berkeley, and so on, and you can clearly see how the demand has surged in the last couple of years. And same is the case for machine learning also. If you just look at the job openings that has come up, you can again see that in the last or since 2016, you can see how the graph has just gone north, right, for skills within the AI domain, such as machine learning, deep learning, NLP, computer vision, speech recognition. These are exactly the things that you'll be learning in the program. Another indicator is GitHub stars, or people who've been recognized on GitHub for TensorFlow and scikit-learn. Again, two libraries and tools that you'll be using in machine learning and deep learning aspect of this program, like TensorFlow and scikit-learn. These are exactly the things, and you can see how even that graph, especially for TensorFlow, how that has just rapidly increased since 2016. And as I was mentioning, right, this is not a US driven phenomenon. This is happening in India. So as per the IDC Intel report released last year, 22% of organizations currently are adopting AI, and that's a huge number, by the way, right? It just opens up so many opportunities, and it is predicted that by mid of 2019, which means this time next year, that number from 22% will actually go to close to 69%, right? So more than 3x organizations would have adopted AI in some form or the other, in a span of 2 years or lesser. Again, 97% of data center servers are running AI workloads, and they're powered by Intel. I mean, that of course is the Intel aspect to it. But focus on this aspect, that from 22% to going to 69% in a span of 2 years. That is the kind of adoption that's happening within the Indian industry. So that broadly, covers the first part of the program that I had, which was all about how AI and machine learning are changing the world around us, and also some thoughts and notes on how to demystify this exciting and yet sometimes confusing, because of all the jargons, world of machine learning, AI, deep learning, data science. And of course, we spent a lot of time on understanding the data revolution and what it really means for all of us, and where can we have a role to play, and how can the future be for us, depending upon what part of that curve do we get into. I hope you found that useful. So the next step, or the next part of this webinar, is about our artificial intelligence and machine learning program, the Great Lakes program, which is also supported by Stewart School of Business at IIT Chicago. So I'll quickly walk you through in terms of what are some of the highlights of the program, and how do we look at things differently and try and train you better for the industry. And then I'll open up the floor for questions, and I'd be more than happy to answer every single question that you have. All right, so first, the boilerplate information. The postgraduate program in artificial intelligence and machine learning is a 12-month executive program for working professionals, right? So you don't have to quit your job to do this program. It is all about that you can learn while you work. The way the curriculum is created is that there is minimal disruption to your work. Across 12 months, you will attend 30 days of classroom sessions, amounting to about 240 hours of classroom learning, where the faculty and industry experts are right there in the classroom in front of you, and you get to interact and clarify your doubts right then and there, rather than learning through rather than your primary learning being through an online medium where interaction gets suffered. One of the reasons why we started this classroom program was because we realized that learning machine learning and AI is not trivial, right? And that is something that I get very disturbed by, if I may use that word, when I see when I see so much of advertisements around this. Sometimes communication tends to trivialize the scope of learning. I have seen communication being put out that you can become a machine learning expert in 30 hours. That's a joke, if you ask me honestly, because even in 12 months, right, I would not really go out and say that you're going to become a machine learning expert. You will become good at machine learning for sure. You will have a very good foundation, and you will have exposure to some actual problems that the world is solving, which makes you relevant for machine learning careers. But the path to expertise is a much longer duration journey, right? Nobody becomes an expert in anything in 12 months or lesser for that matter. So I think it's important that we don't trivialize these things. Machine learning and AI are actual detailed fields of study. And while it is important that you get the right foundation and you learn in a structured manner, what is equally important is that you also continue your learning as time progresses. The program has been designed for mid-career professionals. So the minimum eligibility in the program is 3 years, and the average experience that we usually see is about 7-8 years. So all the way from 3 years to 15-20 years, we get professionals to come and do the program. And again, if when we look at the reasons are very straightforward. The reasons are because they're realizing that either the job that people are doing or the projects that they're a part of are either at risk or are becoming redundant, and these are the future areas that are driving growth. So if you don't upskill yourself in these future areas, you are just robbing yourself from having any opportunity in future growth, right? And that is a massive disadvantage to be at. The blended format, which is the classroom and online format, so the program has classroom learning as well as online learning, primary instruction being in the classroom learning. And there is tons of hands-on work which helps you get better at all these aspects. It's not just about theory. In fact, it is completely application driven. Great Lakes itself has a huge credibility and name within analytics and data science. Our programs have been ranked number one for 3 years in a row when it comes to analytics and data science, and which is why when it comes to AI and ML, also when you learn from institutions of pedigree, there is a distinct advantage that you get in your career. And lastly, we've also added international certificate in this from Stewart School of Business, IIT Chicago. Reason being, for a lot of our candidates, they also go on to pursue careers abroad or they move on site. So there is a fair amount of requirement that comes in when you're moving out of India, and the international certificate from Stewart School lends that credibility, thereby making your education recognizable worldwide. What really makes this program unique? I think the first aspect is the hands-on nature of the program. Right? At the end of the day, we are not trying to make you into a theoretician, right? We are not trying to, let's say, for the lack of another term, the idea here is not to make you into an AI scientist, right? But the idea is to make you into an AI, or to transform you into an AI practitioner. And that only happens when you get to work on labs and projects. So every time that you come for classroom sessions, there are designated lab hours, right, where you will be working hands-on on a problem. Beyond that, there are even more projects that you will be working on. And by the end of the program, you would have worked on close to 9 projects plus one capstone project, which is a much longer duration program or longer duration project, right? Which overall builds a super impressive portfolio for you, right? Because it shows to the world that what you have done and what can you do. And in all our transitions that we see, where our alumni are able to secure, either a promotion or a new job, everywhere we see that it is this portfolio that becomes a game changer. Because when this is often where hiring decisions or hiring discussions start, because when companies are able to see that, okay, this is the kind of work that you've done, there's just a lot more confidence in what you're capable of. The other aspect that we have in the program is that there's an online lab that's available 24/7, and the only reason why that is there is so that you can practice, and do more practice. Ultimately, you'll get better at all of this by by the number of problems that you solve. And that is why we have a large repository of problems, and we enable and facilitate you to practice as much as you want using our online labs. The second aspect that really makes the program unique is the industry focus, right? So the program has been co-developed by industry experts, by our corporate partners, which again are leading organizations in technology, in banking and finance, in research and engineering, right? So this program, curriculum, and the teaching plan and the assessments are all vetted by the industry. Beyond that, we also get a lot of industry professionals and experts to come and teach in classes and also mentor projects. That again adds a lot of credibility, right? Because you're not just learning from some of the best academicians in this space, but you're also learning from industry experts who will be able to guide you better with the actual application of how these problems are getting solved, or how a given technique gets implemented in the industry. And that is an unbelievable learning to have. And when you have that in the classroom, it just enhances your experience so much more. What we also do is periodically we keep doing industry sessions where we get some very senior folks from the industry who come and give you a glimpse of how AI and ML is transforming their organization, what is the kind of work that they're doing using AI and ML within their organization, and what does it really mean. The third aspect is our design philosophy of the curriculum, which is not dated or archaic, right? Our focus is all on current and future. So what you are learning today is basically what will make you relevant for the industry and make you job ready for the industry as soon as you complete the program, right? So the focus is always on what is relevant today and what is emerging. This is also one of the reasons why we do an active curriculum review every 6 months. Every 6 months, the program is reassessed by all our corporate partners, our industry experts, and our faculty to see if there is, some element, or if there are some elements in the curriculum that we should be adding that we've not added so far, right? That makes your learning even more meaningful. You able to build a portfolio of projects which are all contemporary projects, right? These are not dissertations, these are not theoretical, these are actual problems that you're solving. I think I have a slide on that, but you're solving problems that have been solved at Amazon, at Netflix, at Uber, right? You're talking about recommendation systems, you're talking about review and sentiment analysis, you're talking about taxi prediction. So these are actual problems that are being solved. And finally, because there is adoption of AI and ML that's happening across organizations, and I'm sure including yours, you will actually be able to practice what you have learned right at work, right? You will have opportunities to go and start contributing to those projects as soon as your learning begins. So that really brings me to the next part, which is what will you learn in the program. So this, as I've already told you, is a 12-month program, 30 days of classroom, 240 hours of classroom learning, and overall over 400 hours, with about 150 plus hours of online learning, which is a mix of self-learning, recorded sessions, classroom content, projects, assignments, and so on. Now, when you typically start in the program, you will start with the foundations module. This is where we'll brush up your basics on Python that is used for AI and ML. We'll do some visualization basics, and we'll also build foundation on statistics and probability that is relevant for AI and ML. Then the next kind of 5 months are focused completely on machine learning techniques. This is where you learn supervised learning and ensemble techniques. Again, concepts and application, and then use the lab to solve those problems. Then do a project to solve even more problems, right? It always runs in that iterative loop. So the machine learning module that runs for about 5 months will cover supervised learning, ensemble techniques, unsupervised learning, recommendation systems, and reinforcement learning, where through which you will be doing a bunch of problems and projects and assignments and practice sets that gets you better at implementing these solutions. Once you learn machine learning, then you will progress into deep learning, which is all about neural networks, CNN, RNNs, and how that's used for what kind of problems, and what can be the expectation. And this is also where you start using TensorFlow, Keras, and other libraries. Once you're done with the deep learning module, you then progress to the other three broad aspects of AI. One is computer vision, then NLP, which is natural language processing, and finally finally is intelligent agents, which is all about chatbots and so on, right? And again, solve different problems within the scope of these courses. So overall, you can see that this is probably one of the most comprehensive AI ML curriculums that you will see, because it one is that there is a structured path, right? There is no rush here, right? The idea is not to teach you deep learning immediately in 30 hours, right? The idea is not to teach you machine learning in 20 hours. The idea is to give you a solid foundation, give you enough conceptual understanding and building a foundation, and then supplement it by a lot of projects and hands-on work so that you really become good at it. You're not just a theoretical expert, but you're actually a practitioner, and that only happens by exposure. Which is why it begins with foundation, goes into machine learning, then progresses into deep learning, and finally caps it off with vision, NLP, and intelligent agents. So earlier I'd spoken about projects, and you can see that these are some of the projects that I spoke about, right? So overall, you'll be doing about 8 to 9 projects in the program. And when you look at these projects, you can see that these are actual problems that the industry faces. So you're going to do a project where the data is from Uber, and you're trying to do predictive analytics on, using machine learning algorithms on taxi demand, right? And this is a problem that everybody faces, right? So today, when Uber has to decide where should it be stationing its cabs, right? This is the kind of model that they work on. Customer sentiment from Amazon reviews, right? Again, build machine learning models that can determine and predict the sentiment from text reviews on Amazon's website. Visualizing vintage art sales. The other common one that you do is actually, I think, building a recommendation engine using machine learning and AI, using data from a music engine or a music search engine called last.fm. Right? Again, very, very practical uh, for all of you Netflix users or Amazon Prime users or Hotstar users, right? How do they recommend? What should you watch? It is through a similar recommendation engine, and you are actually going to build something like that. In fact, you don't even have to go for an example that far. When you shop online, whether it is Flipkart or Amazon or any of the e-commerce site, you would always see that there is a message or a prompt that says that you are also likely to buy this, or you may also like something like this. That is another case of recommendation engine, right? Again, something that is built on machine learning and AI. So one of the common questions that I do get is, what are the prerequisites of this program? Do I, really need to be like a scientist or a statistician to do this program? And that's not the case at all. Which is why we have certain prerequisites. Our prerequisites are that you should have a bachelor's degree. You should have at least 3 years of professional experience, because that does help. You should have familiarity with high school mathematics. Again, if you are an engineering graduate, then these are already covered. And you should also have functional programming knowledge. And you don't have to be programming expert, or it's not as if you have to do programming right now. But as long as you have functional programming knowledge, and what we mean by that is you understand syntax, you understand commands, you understand the basics because you've done programming at some point in time, either in your college or at your workplace in your early years. That is absolutely fine, because then we are confident that you will be able to pick up Python very easily. And it's important to pick up Python because we do teach Python. It's important to learn that so that you're able to start implementing these models. And in fact, for folks who don't know Python, you don't have to worry at all, because upon your enrollment, we would be providing a pre-program tutorial for you before classes begin, which actually will help you come up to speed in Python. And if you know one programming language, learning another is very, very easy. And in fact, Python is one of the simplest programming languages to learn. One of the things that we are extremely proud about is how our alumni and candidates fare in the industry, and that's what we really mean by enabling career success. So there's a lot of activities that we do to ensure that you are able to project your candidature to opportunities, to relevant opportunities, and you're able to grasp them. So we do a lot of career development workshops, right, where we get experts to come and talk about how should you be pitching your resume, how should you be creating your resume, how should you be preparing for interviews, and they mentor you in terms of, given your background and profile, how should you really pitch your candidature. There's a lot of industry connect that happens, wherein we get industry experts into the class. That also becomes networking opportunities. We also get peer-to-peer networking is huge, right? Because ultimately you're going to learn with another 50, 60 professionals who are all, coming from really good companies and backgrounds, and that always opens up opportunities. Every batch on batch we've seen. In fact, we've seen where, senior professionals have actually gone hired 4 or 5 of their, batchmates into an upcoming ML project or an AI project. And that always happens. We do run a job board in the program wherein we keep posting opportunities, relevant ML and AI opportunities. And at any point in time, you can access the job board and you can, apply to the ones that you think you're a good fit for. Again, that is something that is very, very active. Now that gets refreshed on a fortnightly basis, and every fortnight you will see newer opportunities across leading organizations. These are all opportunities that companies have reached out to us with. So obviously, there is a higher degree of success. Finally, the AIML e-portfolio is a unique proof of concept that you build by learning in the program, wherein you're able to showcase everything that you've done to the outside world, and that also leads, as we've already discussed, that leads to a lot of hiring discussions. And what we have seen is that our alumni across programs work in a host of companies, right? So there are leading tech companies such as Amazon or Microsoft or Google or Flipkart. There are consulting companies, such as ZS, such as KPMG, such as Deloitte. There are banking and financial services companies such as RBS and American Express. And there are marquee names such as McKinsey. And of course, there are a bunch of, associated or allied industries, whether it is in manufacturing, whether it is in telecom, whether it is in energy, whether it is in shipping, right? Where, machine learning is getting implemented. Machine learning solutions are getting implemented, and that is giving an opportunity for people to further their careers, people who are skilled and who are good at this. So the challenge for you is really to learn well and to become skilled at it. As long as you cover those two hoops, you will not be constrained by opportunity, right? And that is a given. So in fact, when we track our own alumni success rate, what we see is that currently about 66%, that is about two-thirds of our alumni, are able to transition to roles in machine learning and AI within 6 months of program completion. So that is happening very, very actively, and the average salary hike that we are seeing is within transitions about close to 45%. Again, extremely high. And mind you, these, it's not as if these are all, young professionals. I'm talking about professionals with 10 years of experience, 12 years, sometimes 15 years of experience, who are able to capitalize on opportunities. So opportunities exist across the spectrum. It really depends upon which are the ones that you were able to capitalize and convert. Okay, so that brings me to the end of what I had to present. um, and I think a few questions have come my way, so let me start taking some of these questions, and feel free to type in more. So I have a question from Vaishak. Vaishak, I think what you're interested in knowing is, why is R not part of the program? So Vaishak, R is more of a statistical language, but when it comes to machine learning and further, building on machine learning, going into AI and all, Python is the language of preference. In fact, you can now research online. I think the latest report suggests that Python has gained market share, and it is now the leading programming language of choice for data scientists and machine learning engineers, with R kind of, slipping down, which is the reason why Python has been chosen over R. Python is also far easier to learn as compared to R. Also, it has a lot of machine learning libraries that makes, implementation of machine learning much easier when it comes using Python. Mohan, your question is that whether ML and AI will deal with big data techniques as well. So big data engineering is a different part, Mohan. So for that, we have a separate add-on module that we are creating, where, the techniques that you learn in machine learning, you can apply on big data. But other than that, big data engineering is completely different. It is more about how do you create and create technical frameworks and work with large volumes of data, right? Whereas machine learning is about how do you solve problems using machine learning techniques. There is, of course, a crossover in terms of
terms of how do you apply machine learning on big data, and that's something different. I have a few questions in terms of the depth of the curriculum. So here I must say that, the way the program has been designed is keeping in mind that it is meant to be a program that's supposed to go very deep in coverage, which is why there are lots of projects. So every course has a project, as you have seen already. Plus, every time you come for classroom sessions, there are dedicated lab hours. Again focusing on the fact that you learn by doing, right? And that's how the entire program is delivered. So depth and application oriented learning are key aspects of the program. I have a few questions in terms of learning support. Let me address them. So the questions are that, while you are going through content or you're trying to do assignments or assessments, if you get stuck, what is the resolution mechanism? So we have multiple resolution mechanisms. You first of all, you will always have access to Olympus, which connects you to your program manager, to subject matter experts, and so on. And you can reach out to your program manager or your SME at any point in time and ask for a technical clarification, and they'll be able to help you. Beyond that, if you want to talk to the faculty concerned, your program manager can also help you do that. We also have a very active discussion forum, so you can always post your queries in the discussion forum, and that's what a lot of our candidates do, and they get their queries resolved by their peers and participants. So all of these are options that are available. Sudhakar, your question is that R, and will that be good enough to learn Python? Absolutely, Sudhakar. So, as long as you know any programming language, that is good enough, because as I said, Python is by far one of the easiest languages to pick up. And R to Python is not at all a hard transition to make. And that's something that you can always do. Anshul, your question is that is there a requisite to learn data science and big data before learning AI and ML? So it doesn't work like that. As I said, big data is an associated field. It's not a prerequisite. For learning AI and machine learning. And data science is a larger bucket item that consists of machine learning, of analytics, and so on. So it's not as if you have to learn data science, before learning ML. In fact, today, if you have to be a data scientist, you have to know machine learning. Machine learning is very much a part of data science. Sharat, your question is, how would the weekend hours look like? So whenever you come for classroom sessions, depending upon whether these are 3-day residencies or 2-day residencies, you will be occupied from 9:30 to about 6:30, 9:30 in the morning to about 6:30, so 8 hours of classroom. Sudhakar, to your question in terms of deployment of algorithm, would you get to understand deployment of algorithm? Uh, Absolutely. This is why you do projects and you do problem statements and you do lab exercises, because it's not about knowing the algorithm, it's also about solving problems using those algorithms, right? And that's where you have to gain exposure. So I'm also getting a questions from few medical professionals, in terms of applications of machine learning in healthcare. So I don't know how aware you are, but actually one of the there's a great deal of work that's happening in healthcare using machine learning, right? So when it comes to tumor detection, anomaly detection, cancer research, you will see that a lot of recent work actually is on the basis of machine learning, deep learning, and so on. And every batch, in fact, we do get some practitioners or healthcare professionals who come in and upskill themselves using machine learning, right, to further their careers. Right. So, question from Vaishak: how long is the LMS access going to be for? So, by policy, you will have continue to have access to the LMS for up to 3 years post completion of the program. So, all your content, everything will be there. Access to discussion forums, access to program manager, faculty, everything will be there for 3 years post completion. There are also a few questions that are coming up around batch, next batch dates and so on. What I would strongly suggest is that please reach out to the admissions team. I have put in their coordinates right here. You can see that on the screen. So reach out to them and they'll be able to advise you in terms of how many seats are left for any of our upcoming batches. I have a question where the question is that is machine learning necessary to learn AI? As we discussed, machine learning is always the first step towards implementing AI-based solutions, right? So, you really cannot implement AI without implementing machine learning, and that's why it is important to learn machine learning and then learn AI. I have a few questions around career services. I think that is something that I've spoken at length about in terms of the various activities we do, whether it is in terms of access to job opportunities or career prep, right? These are all activities that we continue to do. And you will have access to all of those opportunities even after, every week or every fortnight we keep posting new opportunities. Even once you graduate from the program, you will have access, you'll keep receiving these alerts with new opportunities, and that's something you can always benefit from. A lot of our alumni do use those and apply and get transitions as well. Praveen, your question is that will the learning material be in soft or hard copy? So most of the learning material is digital so that you can access it on your mobile phone as well. And we have a learning app. That is why it's kept digital. In some cases, faculty do suggest certain textbooks, and those textbooks are provided. But most of it will be digital. All right, so I think that broadly answers most of the questions that have come my way. Thank you so much for posting your questions. I'll anyways ask the admissions team to also reach out to you and clarify any further questions that all of you may have. Feel free to write into me. I've put in my email ID here. It's hari.nair@greatlakes.edu.in. I would love to, get feedback from you in terms of whether you found this session helpful and what can we do better to make this even more meaningful for you the next time around. So once again, thank you so much for your participation. It was wonderful interacting with all of you, and I wish you the very best. And I hope that you learn AI and machine learning, and you path a career for yourself in these exciting areas. Thank you. All the best.